Hi, hello everyone. My name is Jun Oshima. Let me just start with my slides and explain about our, our presentations. So the title of the presentation is The Current State of Knowledge Building Analytics and Possible Future Directions. So contents of my talk. Uh, First, I'm going to talk about theoretical orientation such as learning as knowledge building. Then go to the methodological issues, for instance, the current state of knowledge building analytics. And finally, I'm going to talk about possible future directions of KB analytics for extension of the algorithm of the discourse-based analytics, as well as multimodality approach. So first, I'm going to explain about knowledge building. Just in case someone doesn't know about it. The knowledge building as one of the theories in the umbrella of the knowledge creation perspective. So the target is a collective knowledge advancement rather than individual improvement of something to learn. But individuals and the community have to hold collective quantitative responsibility to exert their epistemic agency to contribute to the collective knowledge advancement. The finally, the group cognition function as shared epistemic agency proposed by Karina Damse and her research teams. So these three aspects are kind of variables to be evaluated for evaluating the learning as knowledge creation and knowledge building. So what we have done so far, the current state of knowledge building analytics are totally based on, well, the social semantic network analysis. So you see the transcript. I'm sorry, but this is totally in Japanese. In the center of the slide, what we're going to do usually is to detect some important vocabularies, usually nouns, then create co-occurrence adjunct table of keywords on the basis of which we're going to create network of the vocabularies like this. On the other hand, we can do the different thing. Categorize each discourse exchanges into different types like this. So we used, for instance, on this data set, 7 different categories of epistemic actions proposed by the Karina Damse. So the discourse transcript, each discourse exchange, were transformed into categories of epistemic actions. For instance, first line was categorized as creating shared understanding as well as doing some regulative actions. So on the basis of this coding exchanges, co-occurrency adjunct table of categories on the basis of which were conducted different type of network analysis called epistemic network analysis. So these two analyses are quite similar to each other in the sense of algorithm, but because they're doing on the basis of different sets of data or different aspects of the data set, we can see totally different type of pictures of the discourse transcripts. So this is one of the advantages we have right now. So if you calculate, for instance, a very typical measure of the network structure topology, degree centrality, for instance, on the basis of the vocabulary network, you can tell the difference between high learning outcome groups and low learning outcome groups, as you see on the slide. So high learning outcome groups engage in their collective knowledge advancement in the early phases of their conversation turns. and it was quite intensive. On the other hand, if you take a look at the epistemic network analysis like this, we divided total transcripts into the first, second, and third, three different phases. Then see the difference between high learning outcome groups and low learning outcome groups. You can see both students are engaged in the regulative actions that on the different perspectives in the different phases. So they started with alleviating lack of their knowledge, but in low learning outcome groups, they just stacked with alleviating lack of knowledge and the second phase and the constructing shared understanding simultaneously. On the other hand, in the high learning outcome groups, you can see very smooth change from the phase to phase, from the alleviating lack of knowledge and the constructing shared understanding for generating collaborative actions. So this smooth change is totally regulated by students and the group themselves. So at the current state of the knowledge building analytics, we examine the collaborative discourse from the multiple perspectives, idea improvement, or maybe the shared epistemic agency. We can evaluate more accurately how runners engaged in the KB discourse. We can use the vocabulary-based analytics for the collective knowledge advancement, as well as cause-based analytics, epistemic network analysis for shared epistemic agency learners engaging. I think this is the current state of knowledge building analytics, as far as I understand. Then what's the possible future of directions of the research like that? We think more sophisticated algorithms should be developed and applied in discourse analytics. For instance, natural language processing approach, such as cohesion network analysis, proposed by a different research team. And also, we should be more focused on the units of analysis, such as standard size, proposed in the epistemic network analysis, or lifeline links in KBDEX. So these two features are quite important for us to identify units of analysis. So finally, we have to be more keen on temporal network analysis. In doing epistemic network analysis or vocabulary network analysis by using a KBDEX, both analyses are totally based on ordinal scale, first, second, third, blah, blah, blah. But it's not actually the interval or ratio scale. So we have to be more keen or sensitive to the time as function. So if we're going to use the interval scale, for instance, the results we showed in the previous slides could be changed, for instance. We can see the difference between the high and low learning outcomes in a quite different way. So it's the physical temporal network analysis is quite important, I think. So this is one way, the possible future directions. The second possible future direction is multimodal analytics proposed by Ultra or others. Currently, we're developing the quite nice, neat sensor batch, like a name card size. It includes the IR transmitter and receiver and CPU wireless module to share or synchronize the signals and the different mobile devices, and the sound pressure sensor and also motion sensors as well. So these tools and a quite small card size, compact device provide you with the opportunities for detect and analyze learners' nonverbal actions during their discourse. Because our research team have been very much focused on on-site collaboration in a small group. We're not quite sure if we can extend this kind of approach to a huge, massive size of community. But for instance, if you can use kind of video camera and some sort of technological features developed by Google, um, you can detect, I think, for nonverbal actions of piranhas, even if you're communicating online. So this kind of multimodal analytics, including the discourse analytics, sophisticated discourse analytics, are the next generation of the learning analytics for knowledge building discourse. So these kind of things, yeah, I was thinking of talking in Germany that because we couldn't, this is the kind of presentation for the workshop. Thank you very much.